Assalamualaikum, my name is Nurul Ifah Batumanaja Ila Zakira, DE200130. Okay, we are from Group 7. We would like to present you about assignment 2. So for the introduction for the fuzzy logic. The fuzzy logic is definition to embody human-like thinking into the control system. Fuzzy controller can be designed to emulate human deductive thinking, which is the process people use to infer conclusion from what they know. Fuzzy control also have primarily applied to the control processor through the fuzzy language description. Fuzzy logic also used in machine control. Fuzzy logic have advantage that solution to the problem can cast in terms that human operator can understand. So for the experience can be used in the design of the controller. For the Fuji logic but based on basic concept, Fuji metric theory is the mathematical metric can be applied to social and natural situation. So this theory can use the algorithm and algebra to the analyze data. So for the methodology, which is a process the convert controller input into information. The inference machine can easy to use to active and apply rules. For this stage, we have two inputs. We need to convert the Fuji input value. For the controller, two input variable have been defined, which is error and error rate. So as you can see for the project, we have start software design MATLAB toolbox or Fuji logic toolbox. So we have two, which is 3 multiply 3 Fuji control metric and 5 multiply 5 Fuji control metric. So as we see for this, we need to compare and implement for the real-time application and we will end.
Hello, my name is Muhammad Idham bin Muhammad Ashraf Effendi. My number matrix is DE20065. So today I will present for the assignment 2 of the intelligent control system. So I will present for the task 1. That is, I need to design a fuzzy membership function with a 3x3 rule base that can gain almost the same performance as the PID controller. So I need to discuss my outcome based on the transient response plot. So this is the coding I put in my MATLAB. So first of all, I put the clear all and then I open the fuzzy pid.mdl. Okay, then when I put the coding, the file fuzzy PID will open, and this is for the circuit for the 3x3 rule, and then PID controller. Then I click the fuzzy logic controller, and then I put the FIS name, that is fuzzy post 2, and then I just click OK. Next, after I open the file of the fuzzy pid.mdl, I put the coding fuzzy logic designer, and then fuzzy logic designer will open the file, and I need to import a file fuzzy interference from the file, such as like that, and then the fuzzy post 2 Memphis, I click this and open this file. So after that, for the input 1, I put the name is error, and for the input 2 is error rate, and the output is voltage. So for the input one error, the type is Gaussian. For the error rate, I put the trapezoidal, and for the voltage, I put the triangular. Next, after that, for the range of the voltage, negative 1.5 and 1.5. For the input 1 and input 2, I put the range negative 100 and 100. And then I export the fuzzy file and then to workspace. Okay, I choose this and click export. So the file export, the file fuzzy logic designer will export to the circuit. And then after that, for the last part is I need to plot TX for the blue and X3 for the red. And then for the outcome graph, I need to plot in transient response. So this is for the graph that I got from the my simulation. So that's all for me. Thank you.
Okay, next for the task 2, we need to design a fuzzy membership function with 5 multiply 5 rule base that can gain almost the same performance as the PID controller. So we need to compare the outcome of 5 multiply 5 rule base with the 3 multiply 3 rule base. Okay, so I show you how to do simulation. Okay, this is for the fuzzy. We have a design. So for 5 multiply 5, as you can see for the rule, we have 25 rule. So this is 5. So as you see for the input, we have 2, which is error and error rate. So for the error, we also have 5. This is a name for N, Z, P, R, and Q. Same for the error rate. So the output, as we see for the output, for the voltage, we also had the same name, but we use the type triangular. Okay, for the graph, as you see for the graph, we get the 5 multiply rule. So this is for the X, we have 6.74 and Y 9.3794. Okay, that's all for me for the task 2. So after the simulation for 3 multiply 3 and 5 multiply 5 fuzzy logic, so we have comparison which is between this. So I see for the 3 multiply 3, for the graph, we have X 6.6 and Y 9.9334. But for the 5 multiply 5, we have 6.48 for X and Y 9.4128. So as you see for this result, we like to calculate that 5 multiply 5 metric fuzzy logic controller rule will offer better result than the 3 multiply 3 metric result, because the number of the rule is increase and the result is better and more accurate. So for this 5 multiply 5, the system is the faster to achieve the steady state static to achieve the steady static. So this is our result.
For the lastly, there is conclusion. First, fuzzy membership function and transaction response plots are essential components of fuzzy logic system, which is will allow us to capture and depict ambiguity, application, and slow transitions in a fashion that replicates human thinking. Next, transient response plot analysis also give useful information on how the membership value varies as the input value transitions over the fuzzy set. Next, is also an effective tool for modeling and displaying uncertainty and implication. For the lastly is we can create strong fuzzy logic systems capable of capturing the intricacies of real-world challenges. So that's all from me for our group. That's all from me. Thank you.